The first encryption that we'll learn how to break is called WEP, or Wired Equivalent Privacy. This is an old encryption that can be easily broken. The reason why I'm still covering it in this course is, first of all, because, like I said, it's very simple, so it's a good starting point. Also, it's still used sometimes in some networks. Therefore, you can't really call yourself a hacker, and then if you see a network that uses WEP, you'll get stuck and you won't even be able to break into it. So, in this lecture, I'm going to explain how WEP works and what's the weakness that we can use to break it. And in the next lecture, you'll see how we can use this weakness in order to break WEP and get the key for any network that uses WEP. So basically, WEP uses an algorithm called RC4 to encrypt its data. So the way this works is basically, if a client wants to send something to the router, and let's say it wants to send this text data to send to the router, it'll first encrypt this using a key. Therefore, this normal text will be converted into gibberish, as you can see here. This encrypted packet will be sent into the air. So if a hacker captures this packet, as we've seen before, if we open this packet, we'll see that it's full of gibberish. Even though it actually contains useful information, we won't be able to read it because it's encrypted. The access point will receive this encrypted packet and it'll be able to transform it back to its original form because it has the key. Therefore, it'll actually be able to read the contents, which is data to send to the router. The same happens if the router wants to send something back to the client. It'll first encrypt it using a key, send it to the client. The client will be able to decrypt it because it has the key. So the concept is always the same. The transmitter encrypts the data using a key, sends it to the receiver. The receiver is able to decrypt it because it also has the key. Therefore, anybody who captures the packet in the middle, they will get the packet, but they won't be able to see the contents because they do not have the key. So the algorithm and the way RC4 works is actually fine. The problem is with the way that WEP implements this algorithm. And to understand this, let's zoom in a little bit more on each step. So going back to the first step, we have the client trying to send data to the router, and the data that it wants to send is data to send to the router. So in order to encrypt this, WEP tries to generate a unique key for each packet. So literally each packet that's sent into the air, it tries to create a new unique key for it. To do that, it generates a random 24-bit initialization vector. The initialization vector is then added to the password of the network, to the actual key that people use to connect to the network. This generates a key stream, and then this key stream is used to encrypt this packet and transform it into gibberish. So basically we have the key stream plus the data that we need to encrypt gives us the gibberish, and then the gibberish is sent into the air. But before sending this into the air, WEP will also append the initialization vector. This is the 24-bit random number that I said it creates in order to make sure that each packet has a unique key. The reason why it adds the initialization vector to the packet is because once the router receives this packet, it needs to be able to decrypt it. And to decrypt it, it needs the key and the IV. But the router already has the key, so there is no need to send that. Therefore, we just need to send it the IV. So, when the router receives the packet, it has the IV, it has the password or the key, so it can generate a key stream and then use that key stream to transform this gibberish into its original form and read the packet. So, if you think about what I said, you can probably guess what the weakness is. Basically, the IV is sent in plain text. So if you look at this, you can see the packet content is encrypted. So if someone captures this packet, they won't be able to read this, but they will be able to read the IV in plain text. Also, the size of the IV is only 24 bits. Now, considering the huge amount of traffic that can be generated on a Wi-Fi network, this number is not big enough, and the IVs will start getting repeated in a busy network. This makes WEP vulnerable to statistical attacks, so we can use a tool called aircrack-ng to determine the key stream once we have enough repeated IVs, and from that it will also be able to crack WEP and give us the key to the network. So from the previous lecture, we know in order to crack WEP, we need to first capture a large number of packets. This means that we'll capture a large number of IVs. The IVs, because they are short, they will be repeated. Therefore, we'll be able to use a tool called aircrack-ng to run statistical attacks and crack the WEP key. So we're using aerodump-ng to capture the data, and we've seen how to do this before. Then we're using aircrack-ng to analyze this data and break the key. Let's see how to do this in practice. So I already have my wireless adapter in monitor mode, and it's called Mon0. I've also already run aerodump-ng to list all the networks around me. And as you can see, I have only one network using WEP. This is called test AP3, and this is my actual network that I use every day. I just configured it to use WEP to make this lecture. The main reason why I'm targeting the network that I use daily, because like I said, for this to work, we need to capture a large number of packets, and therefore we need a busy network, a network that gets used constantly to capture a large number of packets. If the network is idle, then the process is a little bit complex, and I will cover that in the next lecture. So for now, let's focus on the simplest form, which is how to break into a busy network. So I'm going to copy the BSS ID of this network, and I'm going to run aerodump-ng against this network only. So I showed you how to do this before. I'm going to do aerodump-ng. I'm going to do --BSS ID to specify the BSS ID of the network. Then I'm going to do --channel to specify the channel of the network, and we can see it's running on number 1. And I'm going to do --write to store everything that we capture into a file, and let's call this file basic web. And then I'm going to specify my wireless adapter in monitor mode, which is Mon0. So we ran this command before in the targeted sniffing lecture. All we're doing is we're running aerodump-ng against a specific network with this MAC address, with this channel, and we're storing everything in a file called basic web. I'm gonna hit enter, and as you can see, aerodump-ng is working against my target network. And if you notice, you'll see the data in here is increasing really fast. So this is something that I told you I'll talk about it later when we were talking about aerodump-ng, because I didn't want to talk about IVs at that early stage. So basically what you see under the data column is the number of useful packets that contain a different IV that we can use in order to crack the key. So the higher this number is, the more likely we will be able to crack the key. As you can see, this number is increasing very fast because, like I said, this is a busy network that is being used at the moment by my own computers and my own devices. If yours isn't increasing fast, then don't worry, we will tackle this problem in the next lectures. So for now, we're capturing a lot of data, and this should actually be enough to crack the key. So what I'm going to do, I'm going to go down to my other terminal in here, and if we actually list the files, you'll see that we have the capture file that we specified in the right argument. And like I said, we're always interested in the .cap file. So all we have to do right now is do step 2 in here, run aircrack-ng against the file that we captured in order to crack the key. So I'm going to do aircrack-ng. followed by the file name, which is basicweb01.cap. I'm gonna hit enter. And as you can see, it's telling us that the key is found. So let me cancel this here. And right now, we can connect to the target network, which is called test AP3, using this ASCII password. So you can literally just copy this and paste it, or you can connect using this key. Now, in some cases, you will not see this ASCII password. That's why I'm going to show you how to connect using this key right here, because you'll always get this. So I'm going to copy this. And I'm just going to paste it here. You can paste it anywhere in a normal text editor or anywhere you want. And all you have to do is remove the colons that we see in here between the numbers. So I'm going to remove this one. I'm going to remove this one, and this. And now we can just copy this. And just to show you, I'm actually going to connect from my host machine. You can connect from Kali, but when we enabled monitor mode, we killed a lot of processes, and sometimes even after you restart these processes, getting connected to your target will be a little bit buggy. So it's best to literally just restart Kali and connect again. So just to save all of this time, I'm going to connect from here. I'm just going to click here. I'm going to connect to test AP3, and I'm going to paste the password. So I'm just going to click on show the password to show it to you. Again, the same password. We just removed the colons. I'm going to click on join. And as you can see, we managed to connect. And we can test this connection by going to Google. And perfect. As you can see, it's working. And we managed to break the WEP encryption. In the previous lecture, we've seen how easy it is to crack WEP. All we had to do is capture enough data and then run aircrackng to crack the encryption and give me the key. Now, one problem that we could face is if the network is not busy. If it's not busy, then the number of data will be increasing very, very slowly. Therefore, we're going to have to wait for a while before we have enough data to crack the key. So let me show you an example. I'm just going to run aerodumpng here and list all the networks around me. And you can see I have my test network, my test AP in here. It's using WEP. And if you look under the data, you'll see that it's at 0 and it's not increasing. And even if it's going to increase, it's going to increase very, very slowly. Which means that I'm going to have to be waiting for hours before I can crack this network. So, a solution to this is to force the AP to generate new packets with new IVs. Now, before doing this, we need to associate with this network. So, what I mean by associate is we need to tell this network that we want to communicate with it, because by default, access points ignore any requests they get unless the device has connected to this network or associated with it. So don't get this mixed up with connecting. We're still unable to connect to the network because we need the password to be able to connect to the network. But what we're doing right now is literally just telling the target network, look, I want to communicate with you. Don't ignore my requests. That's all we're doing. So it's something similar to what happens when you just click on the network when you want to connect to it. You still haven't put the password. You're just telling the target network, I want to communicate with you. Please don't ignore me. So in this lecture, I'm going to show you how to associate with the target network so we can communicate with it. And in the next lecture, I'm going to show you how once associated, we can inject packets into the network and force the number of data to increase very, very quickly. First, I'm going to run aerodumpng against my target network, which has this BSSID. So I'm going to copy it. And we're going to use the exact same command that we've been using so far. So we're going to do aerodumpng. --BSSID, followed by the MAC address of my target, --channel, followed by the channel which my target is running on, which is 6. And we're going to store all of this, so we're going to do --write, and we'll call this file ARP replay because that's the name of the attack. And then I'm going to put my wireless adapter in monitor mode, which is mon0. So a very simple command that we done before. We're using aerodump-ng to capture data from a network with this MAC address running on this channel. We're storing everything in a file called ARP replay. I'm gonna hit enter, and as you can see, it's running against my target. And notice the data is increasing really slow, or it's actually not increasing at all right now. Now, to associate with this network, we're going to use a program called areplay-ng. So we're going to type areplay-ng, followed by --fake auth, because we want to do a fake authentication attack. We're going to put 0 because we only want to do this once. We're going to do -a to specify the MAC address of the target network. So I'm going to paste it. I've already copied it. Then we're going to do -h to specify the MAC address of my wireless adapter. And to get the MAC address of my wireless adapter, I'm going to do ifconfig. And it's the first 12 digits of the unspec field. Usually you'd see it after the ether, but when you enable monitor mode, it'll show up like so. So I'm going to copy this, and I'm going to paste it here. And I'm going to replace the minuses with colons. And that's it. It's done. And finally, I'm just going to give the name of my wireless adapter in monitor mode. So a very simple command. We're using areplay-ng, which is a tool that can be used to run a number of attacks. And we've seen using this with the deauthentication attack. We're telling it that we want to run a fake authentication attack. We want to do this once. We're giving it the MAC address of my target network after the A. Then I'm giving it the MAC address of my wireless adapter after the H. And finally, I'm giving it my wireless adapter in monitor mode. Now, before I run this, notice in here under the auth, we have nothing. And we don't have any clients showing up in here at the bottom. Now, if I hit enter, you can see under the auth, it's showing up as open. And you can see we have a new client here associated with the network. If you look in here, you'll see this is the MAC address of my target network. And right here is the MAC address of my wireless adapter. So right now I am associated with the target network, and if I send it anything, it's going to accept it and it's going to communicate with me. Again, I am not connected to the network. I still can't use the internet. I'm literally just associated with the network so I can communicate with it. Now, in the next lecture, I'm going to show you how we can communicate with this network in a way to force it into generating new packets with new IVs, which will allow us to crack the key very quickly. Now that we have associated with our target network, we can start communicating with it and it won't ignore us. So now we can go and start injecting packets into the traffic to force the access point to generate new packets with new IVs. This will increase the number of data really quickly, allowing us to crack WEP networks in minutes, even if the network was not busy like the one that we are targeting right now. Now, there are a number of ways to do this, but in this course, I'm going to explain the most reliable method, which is using an ARP request replay attack. I actually explain other methods in my network hacking course, but they are a little bit more complex and have less success rate. So this is the most reliable method, and it should work against most networks if you have a good signal and a good wireless adapter. So the idea behind this method is to wait for an ARP packet, and I'll talk about ARP in more details later on. So for now, just think of it as a special type of a packet that we're going to be waiting on. Once this packet is sent in the network, we're going to capture it and retransmit it. Once we do this, the router is forced to generate a new packet with a new IV. So, by repeating this process, we will be forcing the router to continuously generate new packets with new IVs. Then, once we have enough data, once we have enough IVs, we can run aircrack-ng exactly as we seen before and crack the key. So let me show you how to do this in practice. Now, as you can see, I'm already running aerodump-ng against my target network, and I have already associated with it as shown in the previous lecture. So the only thing that's left right now is to run the ARP replay attack in order to inject packets into the traffic and force the router to generate new packets and increase the number of data. To do that, we're going to use areplay-ng again, and the command is actually going to be very similar to this command right here. So I'm actually going to copy all of this because I'm lazy, and I'm going to clear this and paste the command here. Now, there are only a few things that I need to modify. First of all, I don't want to run a fake authentication attack, so I'm going to remove all of this. And I want to run an ARP replay attack. Also, this attack does not take a number, so I'm going to remove this number. And I'm also going to replace the A with a B. And we're done. So, if you look at it, you'll see it's actually very similar to this command right here. We're using areplay-ng, but instead of doing a fake authentication attack, we're doing an ARP replay attack. We're giving it the MAC address of my target network after the B instead of the A. Then we're giving it the MAC address of my wireless adapter after the H, which is identical to this. And then we're giving it my wireless adapter in monitor mode. Now, I'm actually going to associate again before I do that. And then I'm going to hit enter here. And what's happening right now is my wireless adapter is waiting for an ARP packet. Once there is an ARP packet transmitted in this network, it's going to capture it and it's going to retransmit it. Once it does that, the access point will be forced to generate a new packet with a new IV, and we'll keep doing this, forcing the access point to continually generate new packets with new IVs. So you should just wait for it right now. We're literally just waiting for an ARP packet to be sent in the air. And as you can see, the number of data is increasing now very, very quickly, which means that we actually managed to capture an ARP packet. This ARP packet got retransmitted, forced the router to generate a new packet with a new IV, and we are continually doing this process, forcing the router to generate new packets with new IVs. So right now we can go ahead and run aircrack-ng to crack this network. And before I do that, I'll actually just associate one more time, and then I'm going to do aircrack-ng and give it the name of the file which we're storing the data in, which is called arpreplay01.cap. So I'm going to hit enter, and you'll notice the cracking process right now will actually require more data packets. The reason for this is I've actually modified the settings of this network so that it uses a 128-bit key, because in WEP you can either use a 64-bit or a 128-bit key, and obviously the 128 key is longer. Therefore, I actually modified the key length for this lecture to make sure it's the longest key possible. And as you can see, we still managed to get it within about 47,000 packets. We have the key right here in ASCII, and we have the key in here in hex, where we can use after we remove the colons. So perfect, now we managed to crack the target network. It was idle, as you could see, there was no data being sent, and we managed to do this by forcing the target access point to generate new packets with new IVs. Another method of increasing the number of data rapidly in a network that has no clients associated with it, or if it has very low traffic, is cork chop chop attack. In this method, instead of directly injecting the ARP packet that we capture, we're going to try to determine the key stream for this packet. Once we do that, then we can create a new packet. So we're going to forge a new packet and inject this new packet into the traffic. This will force the access point to create a new packet with a new IV. We're going to capture it and inject it back into the traffic. We'll keep doing this until the number of data is high enough to crack the WEP key. So, the start of the attack is going to be very similar to the one in the previous video. The first thing we're going to do is launch arrow dump against the target network. So I'm just going to call this chop chop test. And here we go. We have our target network here. The second attack that we're going to try to do is the fake authentication attack. Again, we do this so that the target doesn't ignore us. And as you can see, we're successfully associated with the target network. Now, the third attack is going to be our cork chop chop attack, in which we're going to try to capture a packet and determine its key stream. It's going to be very similar to the fake authentication attack. Just going to paste that here. So instead of having fake auth, it's just going to be chop chop. And then instead of A, we're going to have V for BSS ID. So A replay NG, chop chop, the MAC address of the target network, and then my own MAC address, and then the name of the Wi-Fi card with monitor mode. We can get my own MAC address from ifconfig LAN 0, and then my MAC address will show up like this. So I'll just do another association with the target network. And then I'm going to do my chop chop attack. Now, AirPlay NG is just waiting for a packet. Once it captures that packet, it's going to ask me, do I want to decrypt it and determine its key stream or not? So we're just going to wait for it. I'm going to say yes, please. And now it's working to try and determine the key stream for the target access point. Okay, now I've resumed the video. Just want to show you that we've only reached 86%, but we can still actually use this key stream. It might work, it might not work, but we can still try. And sometimes I remember I had like 64%, and I still was able to forge a packet and inject it and successfully inject it into the traffic. So let's try this. Now the key stream is saved into this file. So now next step is to forge a fake packet. We're gonna do this using packet forge. We're gonna put -0 so that it creates an ARP packet for us. The MAC address of the target network and my own MAC address, same as this, A and H. So I'm just gonna copy and paste them. Here we go. Then we're gonna put destination IP, and we're just gonna set it to 255. And then we're gonna set the source, and it's gonna be 255 again. That's just information that has to be there in the packet. And then we're gonna use the option Y to specify the name of the key stream file, and it's this file, as you can see, file that was created in the previous step. So we're gonna paste that, and then the name of the forged packet. So what do we want it to be called? So I'm gonna call it chop chop forged packet, and that should be
in the W option, sorry, so that's the option. So let's just go again over the command. It's packet forge ng -0 to make an ARP packet, the MAC address of the target network, the MAC address of my Wi-Fi card, then we put the destination IP, source IP, and then we put the file that we created in the previous step, and the name of the forged packet that's going to be created. Now the next step is where we're going to inject this forged packet into the traffic and to cause the number of data to increase rapidly. So I'm just going to go to fake authenticate myself again, just in here, and then I'm just going to clear this reply ng to inject our fake packet into the target network. So -2 for the reply attack, and then R to choose the fake packet, and then we put the name of our Wi-Fi card. So -2 for replay, or the name of our packet, the first packet, and -0. So I'm just gonna associate myself again, and I'm gonna hit enter here. It's gonna ask me, do I want to use this packet? I'm gonna say yes. And here we go. You can see the number of data increasing very, very quickly. Again, I only had 86% of the key stream. I wasn't able to decrypt the whole key stream, but the attack is still successful. That's why I've had good luck with this attack with networks that are far away, or with stubborn networks that the first method didn't work against. So all we have to do now is just wait for the data to reach around 20,000 and fire up aircrack ng again, as we did in the previous two videos, and it's gonna work. It's gonna get us the key straight away. I'm just gonna do it here. I can do that here. Let's just clear that. And the name of the file is chop, I think. So it's chop test 01. Yeah. And here we go. As you can see, we got the key with 23,000 IVs. Basically, just I'm going to go again through the steps of this method. So we capture the packet. We try to determine its key stream. We only determined 86%. We used that 86 to create a fake packet, and then we injected that fake packet into the air. The third injection method that we're going to talk about is the fragmentation attack. The fragmentation attack is very similar to the previous one, but in this attack we have to obtain 1,500 bytes of the PRGA, the pseudo random generation algorithm. Because we need to order the full 1,500 bytes, this attack is we need to be closer to the target network to successfully run this attack, but it's much quicker than the correct chop attack. So again, after we obtain the PRGA, we can use it to forge a new packet, and then we're going to inject this new forged packet into the traffic to increase the number of IVs very quickly. So the concept is very simple. We're gonna capture a packet, determine its PRGA, forge a new packet, and then inject that packet into the air. So let's see how we can do this. Again, first thing is going to be running arrow dump against the target network. So I'm just gonna change the name here from chop to fragmentation. We're just gonna call it fragment. Hit enter, and here we go. Arrow dump is launched on our target network. Second step, as always, is fake authentication, so that the access point doesn't ignore us and starts communicating with us. So we do that, and we see here we have successfully associated with the target network, and the authentication has changed to open, so that's very good. Third step is going to be our fragmentation attack step. It's very similar to the chop attack. So you can see here that's my chop code that I used, the chop command, sorry. So it's exactly the same command, just instead of chop chop, I'm gonna say fragment. So it's airplay ng fragment, b the target address of my target network, and then h the MAC address of my own network. Of my own Wi-Fi card. So I'm just gonna associate myself again and do the fragmentation attack. So it's waiting for a packet now. Once it captures that packet, it's gonna try to determine its PRGA. And here we go. We got a packet. So it's asking me, do I want to use this? I'm gonna say yes, please. Now it's trying to determine the PRGA. So that packet wasn't useful. It's just waiting for another packet to use. It's asking me, do I want to use this? I'm gonna say yes again. Again, that packet wasn't useful, so we're just waiting for another useful packet. I'm gonna reassociate myself in the meanwhile, and I'm gonna say yes. Okay, now this time this packet was useful, and the key stream is saved to this file. Okay, now we're just gonna need to, again, the same as we did in chop chop, we're gonna use this key stream to create a first packet. So I'm just gonna copy its name, and I'm gonna use the same command. I'm just gonna clear this for you, and I'm gonna use the same command that we used with the chop chop attack. The only difference is I'm gonna remove the Y, and I'm gonna put the name of the new key stream that we captured, and the name of the packet that we're gonna create, I'm gonna call it fragment first packet. So we're just gonna go over the command again. It's packet forge -0 to create an ARP packet. A, we put the target MAC address. H is my own MAC address, and then K and L are the destination and the source IP addresses. Y is the name of the key stream file, so it's the file that has been created from the previous step, and that's the name of it. And then W is the file name that's going to be created, that's going to contain the first packet, and it's going to be called fragment first packet. And it's telling us that it's been successfully written to this file. So again, just like the chop chop attack, we're going to inject this new packet into the air, and this is going to be done using airplay ng with the -2 option, the reply option. Just going to paste the name of my new first packet. So we got airplay ng -2 for the replay, or the name of my first packet, and 10 is my Wi-Fi card with monitor mode. Before I do this, I'm gonna associate myself again, and then I'm gonna hit enter here. It's asking me, do I want to use this packet? I'm gonna say yes. And here we go, we can see the data is flying. We're injecting around 400 packets per second, and once this number is large enough, we're going to be able to crack the key. I can just go here to air crack ng. So it's going to be air crack ng fragment test. .cap, and here we go. We can see the key. That's the WEP key, and we have 30,000 IVs. So if we go back here, it's probably even more. It's 35,000, and the numbers are increasing quickly. So that was the 3 methods to inject packets into the air. There is more methods, but that's in my opinion the best 3 methods to increase the number of data into idle networks. This way we're able to crack any WEP encrypted network.